Welcome to the Hovercrafter's final presentation. So we were tasked with building a hovercraft, and initially we planned to construct a more traditional hovercraft, and the diagram shown on the right there was our model. So it was going to be about 1.5 feet wide and 2 feet long, so larger in size. It was going to have two downward facing and two backwards facing computer fans that were ducted. We were going to place a curtain around the perimeter of the base to allow the airflow to be more efficient. And we were going to build a body out of a lightweight material like styrofoam or foam. And we planned on building a circuit on board using 12-volt batteries and copper wires.
We created our first prototype, and that had four fans that faced downward, and we did that to see how the fans would fare when it came to lifting the hovercraft. The four fans collectively weighed about a pound, which turned out to be a bit too heavy to lift the hovercraft up as a whole. The ducted fans themselves did not give off enough power to lift the hovercraft, even though we used a 24-volt power source with our prototype. Therefore, we decided to design an entirely new hovercraft.
After the failure of the first design, we scoured the internet to find a new design that might work. One of the designs we found was similar to our initial sketches, and that's the design we chose to go with for the final project. I constructed the base out of foam and the skirt out of a section of trash bag, both using the dimensions and techniques described in the video on the previous slide. The base and skirt were held together with hot glue. The scoop on the back was made from a piece of cardboard and held on with duct tape. The fans were made from an aluminum sheet that was cut out and formed to the proper shape. The fans were secured to the motor shafts using hot glue, and wires were soldered onto the motors. The wires were held on to the battery using electrical tape, and the craft was turned on by connecting the wires together. We began by using 12-volt batteries but switched to using 9-volt due to power issues.
As we discussed earlier, our first prototype did not work at all. It wouldn't hover. So we decided to create a second prototype. That design was also flawed because even though it would lift up, it would not necessarily move forward. So to fix that, we decided to add another fan, the one shown at the right, to make it move faster forward. We also realized that the batteries we were using were not really powerful enough to move the hovercraft. So we bought more batteries, the ones shown at the bottom right, to make our prototype work.
When our group presented at Fed, we came up short of our expectations. While our hovercraft did run, it didn't create enough thrust for its own body weight. When turned on, it began to run and slowly turn off course, and then began to stop working. The judges were not exactly impressed and did not give us a score for that section of the competition. When we were judged on the presentation of the hovercraft at our table, we went through our design, how we prototyped, and the research behind the prototyping. In the end, we tied for last with two other teams.
If we could do things differently, for starters we would have tried to use a different base material than foam. Although its conductivity allowed us to easily create the circuit, its mass was too great and it was the biggest reason why our craft couldn't propel forward. We would have also have ducted the fans, specifically the rear fan. Ducting would not only focus the air and create greater propulsion, but also would keep the air moving straight back, helping the craft move straight forward instead of veering to the right. We would have tried to tilt the lift fan downwards in order to maximize the amount of air dedicated to lifting it off the ground. Also, we would have tried different batteries and at a different orientation to try to relieve the weight that they added to the hovercraft since they were much heavier than we expected. Finally, we would ensure that the weight was evenly distributed throughout the entire craft to help make sure it stayed straight during travel.
The best advice that I could give to someone on how to do well at FED is to start early and work hard. The problems that we encountered throughout the project could have easily been fixed if we had started earlier. Also, staying consistent with your group meetings is important because maintaining to further your design is an important factor in creating a working project. Another way to ensure that your project works is to test and develop parts of your design independently in order to ensure that they work well when you put them together. But other than stressing over how you perform, focus on having fun with the design and enjoy the process.